All right, thank you very much, Seth. We have a lot of really exciting things to talk about today. I can't wait to share them with you. But first, what I'd like to get started with is just a brief talk about our history and growth to get to this point. 2 years ago, in 2015, we held our first HashiConf ever in Portland, Oregon. We had over 300 attendees show up, and it was at this HashiConf that we announced Nomad. Nomad is actually a big part of this keynote today, and we have a lot to talk about with Nomad, so you're going to hear a lot more about that later. Then last year, we had our conference in Napa, California in 2016. And at this conference, we announced new funding to help grow the business, better cross-product integrations, and as we started to commercialize, for the first time ever, we had customers come on stage to talk about how they're using HashiCorp tools at enterprise scale. And at that event, we had over 500 attendees. And today, we're here in Austin, Texas, at HashiConf 2017. And as Seth said yesterday, we actually had almost 200 students in 5 sold-out trainings learning about HashiCorp tools. And today, you're surrounded by almost 800, over 800 actually, total attendees here at HashiConf. I see familiar faces. I saw familiar faces in the crowd. I saw some people that I know were at HashiConf 2015. And thank you so much for being so supportive of what we're doing. And over the next 2 days, we have over 35 talks planned. And these are given by trainers, speakers, users, HashiCorp employees. You're surrounded by the experts on HashiCorp. Anything you want to find out, you have the people around you to figure that out. And so we hope you enjoy learning from each other as much as you do learn from the talks. And so now, I'd like to just talk about the progress we made in the past year. About a year ago, HashiCorp was just about 50 employees. And just over the last 12 months, we've grown, in fact, to over 130 employees. And it's inspiring to see everyone wearing the HashiCorp logo continue to care so deeply about the community and our customers. And in addition to this employee growth, we've had really significant community growth as well. Last year, we had our first ever Hug events, and this year, we had over 42 Hug events with a total of over 7,000 members all around the world. You could see a pin just about everywhere around the world. This year, we also had our first ever Hashi Days events. These were single day conferences with about 200 to 300 people, and we did 2 this year. We did one in New York and one in London, and both of those were really, really great events. And in addition to the employee growth and community growth, this has helped fuel growth in the products themselves. And so this year, over the past 12 months, we've actually released over 150 total new versions across our open source products. Over a 12-month period, that is the most number of releases we've ever shipped. These releases include, thank you. These releases include major features, improvements, as well as thousands of bug fixes. We're continuing to improve our products regularly. In addition to just the release numbers, the download numbers are equally exciting. Over the past 12 months, we've had over 22 million downloads across our product line. And just in the past 30 days, we've had over 1.5 million downloads, which is the most we've ever had over a 30-day period. So in addition to this amazing growth of our employees, our community, and the products, we've also seen fantastic growth in our commercial products. Last year, we announced Terraform Enterprise and Vault Enterprise, and earlier this year, we released Consul Enterprise. Through these products, we've been able to grow revenue quarter over quarter, and this allows us to reinvest back into our company and open source communities, and lets us throw events just like this. And HashiCorp wouldn't be anywhere without open source software, and we and I absolutely love open source software. But at the same time, we're trying to ensure that we build a sustainable company that could continue to deliver high-quality open source software. It's what we want. And so what we do is we take features that assist with collaboration and operational needs of larger teams, as well as governance and compliance concerns, and we put those into enterprise products. It's obviously not a simple decision. we've been working over the past 18 months on building a framework so this is understandable, repeatable, and no special cases. And we intend to publish a blog post by the end of the year detailing that exact framework. But thanks to this process and thanks to our enterprise products, we've been able to continue to grow. And just on this slide, you could see some of the logos of our growing customer base. Most of these logos became customers this year, and I think it's really, really amazing. And in addition to those logos, these are the list of companies that are speaking at HashiConf this year and presumably are therefore using HashiCorp tools, which is absolutely amazing. And from this growing customer base, it's clear to see the trend that cloud adoption is in full force. It's what our software does best. Every major company is either undergoing or planning a transition to the cloud. And what this is looking like is going from a traditional data center, a self-contained unit, where if you zoom in, you'll see a core infrastructure layer that's providing the physical resources necessary to run applications, and an application layer, maybe this is virtual machines, maybe it's schedulers that are deploying applications on top of this infrastructure layer, and then surrounding that, a layer of security. And we're moving that into clouds, whether it be private cloud, public cloud, Google, Microsoft, Amazon, whoever it may be, these companies are planning transitions to the cloud. And we're here to help with that, because while you do that, a lot of these components remain the same. You still require a core infrastructure layer. You still need resources to run applications. Above that, you still need an application runtime layer. There's still a need for something to coordinate the deploys and operational tasks to actually run applications. And then in this view of the world, there's no more clear perimeter, network perimeter, and so security just has to be a part of all of this. You have to think about security all the way through. And then with the cloud, with multi-cloud, with multi-data center being a default, with all these different things, there's a new challenge, which is connecting, discovering, and communicating across these three layers. And so what we try to do as a company, what we try to do with our software, is enable you to provision, secure, run, and connect any infrastructure for any application. And with that, I'd like to begin talking about the product updates within these four categories. And let's start with Terraform. So Terraform over the past year has grown significantly. The number of providers has grown by over 20. The number of resources has grown by hundreds, and the number of contributors is well over 1,100. We've also established close relationships with all major cloud providers and are working together now to move towards 100% coverage of all resources within Terraform. And this list is actually just some of the updates that we've shipped to open source just in the past 12 months. And just as I said previously, this is actually the most we've ever shipped into open source over that 12-month period. And just to highlight a few, we've shipped the ability to have conditional values within your configurations. You have the Terraform console to play around with Terraform values in a REPL-type environment. There's Terraform import, so you could import single resources here and there that weren't under Terraform management before. And then just recently, we announced local values so that you could actually have local variables within your Terraform configurations. So from improved stability to rich new capabilities, we've consistently been delivering to make Terraform a better and better product. And this is what's helping drive Terraform to grow as much as it is, in addition to the partnerships and community. And all of this growth and maturity is really quickly solidifying Terraform as the standard in infrastructure provisioning. Terraform could be used to provision any infrastructure for absolutely any application. And in striving to continue to make Terraform this standard, we're happy today to announce the Terraform Registry. The registry is a place to find verified and community modules for reusable infrastructure components, as well as a place to get started and learn about Terraform best practices. We and our cloud providers, cloud partners, have seeded the registry with modules for the most popular services for the most popular clouds. These include basic modules such as best practice network layouts, as well as full application deploys such as Console, Vault, and Kubernetes, and these work across all of these cloud providers. We have verified modules, which are recognizable by the blue check mark. And the verified modules mean that they've been vetted by HashiCorp both to work properly, but also with the maintainer themselves to ensure that they're updating the module and keeping it compatible with the latest version of Terraform, as well as the latest best practices of that cloud provider itself. So, for example, Microsoft is actually writing the Azure modules to ensure that you're working with Azure the way that Microsoft really believes you should work with Azure. And in addition to verified modules, anyone can publish and consume their own reusable modules. But instead of telling you how easy that is, I'd like to show you. And it's really that easy. This video went from having no account and never using the module registry to signing up, publishing a module, and having it available, and it wasn't sped up at all. You could go from nothing to publishing a module in about 15 seconds. And as you can see, we surface a lot of information about modules. And one of the most exciting things is the module registry brings to Terraform the concept of module versioning. Every module within the registry has a semantic version associated with it, and we allow you to navigate those versions within the registry UI. Additionally, when you publish a module with the registry, what the registry actually does is bring in the module, parse the Terraform code, learn about it, and use that to generate help and documentation about that module. So you could see on this page that we have the README rendered. We have a list of inputs, a list of outputs, the list of resources it might create. We also parse out a list of other module dependencies, whether they're in a module registry or actually anywhere else, Git, S3, anywhere else. And we show that to the user, and you get that automatically. There's no metadata you have to type up. We parse that out of the Terraform code itself. And the Terraform registry is available today, right now, at registry.terraform.io. Today, we've also released Terraform version 0.10.5, which allows you to use the module registry modules. And later this year, before the end of the year, we'll release Terraform 0.11, which contains significant improvements to the module system, including the ability to constrain by module versions. But every module that's in the registry today is already versioned. And with that, what I'd like to do is invite Corey Sanders from Microsoft on stage to talk about Terraform and the module registry.
Thanks, Mitchell. Good morning, everybody. Excellent. Wow, a lot of people here. This is great. This is my first time actually at HashiConf as well, so I was raising my hand backstage. And one of the biggest things for me was trying to figure out what outfit I was going to wear. This takes a lot of deliberation when I'm up on stage. Probably could be spending more time working on products, but instead I'm worried about what I'm wearing. And I wanted to make sure I represent as many of people in the audience as I could. And so I wanted to make sure I got the jacket for enterprises in the room, so please focus on this part of my outfit. Okay? And then for startups, feast your eyes on this. So now we got a little bit of Star Wars going on underneath. So. And let's do it again. Enterprise, startups. Good? Okay, great. All right. Now everyone's ready. All right. So one of the most exciting things about working with HashiCorp has been work around Terraform. And it's something that we came out and announced actually just a month ago that we were going to be increasing a lot of investment to make this work really fantastic on Azure. And I'm so excited just a month later to be here on stage and to be able to walk you guys through some of these things that we've already put in place. And so first, as Mitchell was just talking about, the Terraform module registry. This thing is fantastic. Announced today, we actually have released 8 certified Azure modules that you can use starting today. And it just makes it so much easier to do complex things in a really, really easy way. So you can go check this out. We've got support for compute. We've got support for networking. We've got support for SQL. And of course, Console and Vault also integrated as well. And so all this is available right now. And to give give you a sense of sort of how easy this is and how simple it creates, makes it for you to create resources. If you take a little look here at this example, if I were just creating a network on Azure today using Terraform, you can see I have to go in, I have to create my virtual network, I have to create my subnets and define what those look like, I have to create the security groups, I have to create all the rules, and this is great. If you want this type of control, you want this type of configuration option, you can go do it. But what's great about using a pre-built module is it's incredibly easy for just getting started in many of these scenarios. And so this is what it looks like using our module for the network. And so you can see very, very simple, just a few lines here to be able to create that same full network that I showed you. And just when you go through initialization, it pulls down the module, and away you go. And so this is how easy and how powerful this new capability is with Terraform, and I'm really excited to be launching today with 8 of those certified capabilities built right on Azure. And so that's fantastic. One of the other aspects of the partnership that's been really fun is one of the more beloved features of Azure is our Azure Cloud Shell. So the Azure Cloud Shell is built into our portal experience. So if you go to our portal experience, you can open up our shell. It's effectively a command line in the browser. And behind the scenes, we're spinning up a Linux container on your behalf so you can run commands. And it's got a bunch of commands pre-installed and pre-configured. And one of the things we are announcing today is, as part of this command line experience, we have Terraform pre-installed and pre-configured for you to be able to run commands against this. And so let me actually show you what this looks like. So this is the command line experience right here in the portal. And you can see Terraform is available there. And if I expand that out, you can see just how easy it is to get started. And so it's already been configured. It's already been set up with credentials. And away I go with initialization. And I can deploy. And just how simple this is. There's no additional setup. There's nothing else to really learn. You can get going with Terraform right on Azure almost immediately. And the beautiful thing about this goes anywhere you go. So anywhere you go, you can open up this portal experience. It's any browser, any type of OS, Windows, Linux, Mac. You can run this and get it going. The other aspect that you can actually run it on your phone as well. So iPhone, Android, you can pull this up and you can run these commands. And by the way, of course, this isn't restricted to only run against Azure. You can use this to run commands against any cloud if you so choose. And so this gives you really a nice experience to be able to get going with Terraform or continue going with Terraform if you're already there. So this is exciting. Like I said, we're announcing this today, so go play with this. And it is available directly in our portal experience. And then the last thing to talk about is our provider momentum. This is something as part of the announcement that we made about a month ago. We made the promise that we would make our provider updates. We would make sure we kept up with any of the announcements that we're making and kept the providers to date. We have launched 2 new things in the last month, and both are already available in the Azure provider for Terraform. So these are within days. These are available for you to be able to use directly with Terraform. And so examples of this, Event Grid, which is events as a first-class citizen in Azure. So event objects available today, and our container instances. This allows you to spin up container instances just like infrastructure within seconds, and they're billed per second. And this is also available today. So it's been fantastic. The partnership's been wonderful. We've seen a lot of exciting customer usage. It's been great to work both with the community and with HashiCorp on all of these great investments and deliverables. And really looking forward. The partnership has really just begun. So there's so much more for us to do. If you've got feedback, comments, I'll take them right now. No, just kidding. Come to our booth and meet up with us. We'd love to talk with you more about the work we're doing. And with that, come on back up, Mitchell.
All right, thank you very much, Corey. That's all super, super exciting stuff. And so the next thing I want to talk about is how provisioning infrastructure is, of course, not a solo activity. It's a collaborative activity. Multiple people work together to build and maintain infrastructure. And over the past year, we focused heavily on improving these collaboration features. And in open source, we shipped remote backends, which are a marked improvement over remote state. And we've also introduced state locking, whether you're using S3 or Console or other backends, directly into open source to try to make collaboration safer and more easy. But we also have Terraform Enterprise, which is our tool that's purpose-built for safely collaborating on infrastructure. And over the past year, we've spent most of that year redesigning and re-architecting Terraform Enterprise to feel like a much more natural extension to Terraform. A user of Terraform should be able to adopt Terraform Enterprise and feel right at home with a lot more power and a lot more safety. And so this re-architecture was done in collaboration with some of our most loyal customers, and we're excited to show you some of it today. The first thing I want to show you is workspaces. We've made workspaces the primary place of work within both Terraform and Terraform Enterprise. So when you're adopting just Terraform on its own, you have the Terraform Workspaces command. You don't need to use Terraform Enterprise to get that. Workspaces are a core part of how you work with teams with Terraform using any kind of backend. But when you use Terraform Enterprise, we list your workspaces right here in an easily browsable way. With the workspaces, you could view each one, you could view its history, and you could view who has access to it, as well as what they're currently doing. And when you adopt Terraform Enterprise, Terraform actually offers to migrate all your workspaces from whatever their backend they're currently in over to Terraform Enterprise. And equally, if you choose you don't want to use Terraform Enterprise, we offer to migrate them back out. And so adopting Terraform Enterprise using Terraform with Terraform Enterprise is now a much, much more seamless experience. We've also redesigned the plan and apply pages to look a lot more like Terraform and to also just surface the information you want to see. And so when you click into a workspace and click into a run, this is actually what you see today. You see the run, who triggered it, the commit that triggered it. That links directly to Bitbucket or GitHub or GitLab, whatever you're using. You see the plan, who confirmed the plan, who said it was OK, maybe some comments there. I'm not sure if you could see it, but you could see the person reviewed the plan. If you click View Plan, you could actually see what was planned, and then it applies, all in one place. And this is all stored, and the history is all visible. And we've also rebuilt Terraform Enterprise on top of an API-first architecture. So it's built on top of an open API specification, which lets you control every aspect of Terraform Enterprise via an API. So now you could build automation around Terraform Enterprise, integrate it into your existing software, and as well as just fully configure it using infrastructure as code and use Terraform Enterprise. And then finally, we've moved the home of Terraform Enterprise to app.terraform.io to better represent that it's simply an extension of Terraform and something that improves Terraform with teams. Terraform Enterprise is open. This new Terraform Enterprise is available as a beta today, and will open general signups before the end of the year. And next, what I'd like to do is invite Armon Dadgar, HashiCorp founder and Co-CTO, to talk about some more exciting product updates.
Thank you so much, Mitchell. And thank all of you guys for being here. We really could not do this without all of you being a member of our community and showing up and supporting us. So thank you so much. You are what makes all of this possible. So I'm super excited to be able to start today by talking about Vault. We open sourced it about 2.5 years ago. And few people know that it started life as an internal project. It really started for us looking at how we solve our own secret management problem. And in sort of talking with users, talking with customers about the challenges they're facing, they really convinced us that this is software that we should open source, that there's actually this much bigger problem with the way we think about and handle modern sort of infrastructure security, and that Vault can play a pivotal role here. And so over the last 2.5 years, what we've seen is an incredibly broad adoption of Vault. Honestly, much, much more so than we even expected ourselves when we opened it. And I think the lesson for us is that modern security software is becoming much more important than ever before. And so the question for us when we started trying to understand this was, what's really changing? Why is this happening now that all of a sudden there's this sort of renewed focus and sort of excitement around things like Vault? And I think it really goes back to what's changing about how we think about network security, how we think about application security. When we kind of look at the way we used to do it, it used to be sort of this castle and moat approach. We had these fortified walls that were the outside of our data center. We had a single drawbridge, which was our ingress and egress. And we layered our firewall and our intrusion detection system and our web application firewall and all of this sort of network-based middleware that provided the security. And then we said, once you're inside that castle, everything is safe, right? We don't have to worry about it because we secured everything at the entry and exit. What we've seen over the last few years is as you go multi-data center, as you go public cloud, as you go public-private, these network topologies get more and more complicated. And so you go from a single drawbridge to 2 drawbridges to 10 drawbridges, and at some point you really have no idea how many drawbridges there are anymore because you have mobile devices that are on the corporate VPN that's linked back to the sort of prod fabric, and so it's almost impossible to even understand what the network topology looks like. And so this starts changing that assumption, where before we said, you know what, we can just say, if you're in our network, everything is secure, we don't have to worry about it, to now we have to rethink this a little bit. We have to actually consider that, really we have to protect the infrastructure even if you're on our network. Our applications should not assume that you're authorized, that you can do things just because you're on the network, right? We've learned that this is sort of a fatal assumption, and we can see these fatal assumptions sort of in the news all the time. And so with Vault, what we really think about is, OK, how do we start solving this? How do we change the assumption of security? And then what do we need to do to address it? And there's really 3 totally different axes that we see. The first one, which is really where Vault started life, was secret management, was looking at things like database credentials, API keys, TLS certificates. How do we securely distribute these things to our application if we're no longer hard coding it in the app or storing it in plain text? We really need to have sort of a more sophisticated automation around how we manage and distribute those things. And so that's really what we mean when we talk about secret management, is how do we get these sensitive credentials to our applications that need them in the data center? Then when we started thinking about this problem and really building out the secret management side of things, it became clear that one type of secret, a very special type of secret, was encryption keys. Right? On the surface, it's not that different from any other type of secret. It's just a short string with some bits. But then what became clear is if we treated it like a first-class concept and we sort of thought about it in a different way, then all of a sudden we could provide these much higher-level APIs. We could think about keys as things that we're versioning. We can provide high-level encryption APIs, decryption, HMAC, all sorts of sort of cryptographic operations. And so it goes from just thinking about it's a string that we have to hold to it's this sort of first-class encryption as a service tool, so that we don't have to worry about implementing cryptography correctly in our end applications. Instead, we can just call out to Vault, which is doing it for us. And so once we got this far along, then the question became, well, why do we have these 2 different sources of truth? One system for our human operators, one system for our applications. How do we keep these things in sync? This is just sort of, both bad practice from a security standpoint and introduces a possibility that we're not going to do things right. So how do we centralize everything? And so this became the next axis for us, which was how do we do privileged access management and make sure that the system is easy to use for our human operators who need to interface with it. So that is a lot of things to tackle, 3 totally different kinds of subproblems. And so over the last year, we've been incredibly busy in the Vault team, adding all sorts of new features and capabilities to better do all 3 of those things. Right? And so we don't have time to go over all of these things. I think one of the ones that was most exciting over the last year was the ability to have secure plugins, so that we can really continue down that mission of there should be a single way to broker access to these secrets, regardless of the backend technology. So while we can add support, and we are adding support all the time for new clouds and new databases and new systems, the plugins let us really extend that last mile to just about everything. And now I'd like to welcome Dan McTeer on the stage from Adobe to talk about how they're using Vault in their environment.
Hey everybody, I'm Dan McTeer. Glad to be here. Every time I'm in a situation like this, I'm reminded of a poor life choice I made in college. We had to take public speaking. It was a required class, which I think is a great idea. The semester that I signed up for it, they happened to be offering it online. So in spite of understanding the irony behind that, I went ahead and signed up anyway. So I'm going to dig really deep into all those experiences I've never had and use those to my advantage today. So I work for Adobe Digital Marketing. For those who aren't familiar with that, we actually process over 100 trillion transactions every year for our customers. More than 2/3 of Fortune 50 companies are our customers, and that includes 8 of the top 10 internet retailers, all of the top 10 commercial banks, all of the major automotive industry manufacturers. So we have a pretty big customer base, pretty critical things going on. Our customers exist in just about every market and every industry you can imagine. In 2016, we provided a report that predicted the online sales for Thanksgiving and Black Friday and Cyber Monday within 99% accuracy. So we have our hands in a lot of different stuff going on online. If you've ever been onto like a major TV premiere, cable provider channel like HBO or something like that, and asked for your cable provider, that's one of our products. If you've ever streamed the Super Bowl on a mobile device, also one of our products. So our product suite is made up of more than 23 different digital marketing tools, and those are built and maintained and operated by over 50 different teams, developers, operations staff, and those teams, we like to embrace diversity, right, at Adobe. We do a really great job of that, but part of that includes everybody having their own opinion about what tool works best, and using all of those tools to manage our day-to-day work. So those products run on a foundation of more than 100,000 hosts all over the world in 4 major regions, and they span across to Azure, AWS, and Adobe data centers. My team is part of a larger organization that provides core central shared services for all of digital marketing. That includes things like DNS, Git, DHCP. My team in particular provides security-related services, so things like LDAP, Splunk, Vault, obviously. So the opportunity for sprawl in situations like this is just off the charts. There are so many different tools to use in the different clouds, different open source tools available. You can have one piece of information over here and a completely different piece of information over here. How do you keep those things in sync? And on top of that, we are constantly fighting the battle of, people have so much time to do certain things, security requirements, compliance requirements across all these different industries that we have to abide by, make it difficult for our operational staff to kind of keep up sometimes. So our team philosophy is that we take on the brunt of the security and compliance requirement work, but we make sure our services are easy to consume, are flexible, so that other teams can spend a lot of the time focusing on the customer, on the operational side. So we're always looking for tools that, like I said, are flexible, are easy to use, have a REST API. REST API is key because everybody has different configuration management tools. Everybody has processes they follow. We want to make sure that those things are also simple to deploy, so any market we pop up in, we can be ready to go in a matter of hours with the services that we provide. So the choice was simple from our perspective. We've had tools that are industry leaders in secret management, deployed at different parts of Adobe. Vault Enterprise was the clear decision for a lot of different reasons. It's great to see the message today that how agnostic these tools are, how many different places they fit into, and Vault is obviously no exception to that. So we have clusters deployed in 4 major regions across the globe. Each of those regions has at least three Vault clusters, one in AWS, one in Azure, and one in an Adobe data center. And those are all linked together by an underlying network fabric. If you have questions about that later on, please feel free to talk to me. This has done a number of things for us that have just been fantastic. A couple years ago when I started working at Adobe, we had a privileged account password rotation process that would take sometimes 2 to 3 hours every time we would rotate the password. With the implementation of Vault across the globe and some updates to those processes, we've cut that down to about 30 seconds every time we rotate those passwords. And when you're talking about thousands of hosts, tens of thousands of hosts, that's a huge deal. Not only that, we've integrated that with our Bastion host solution so that you can do privilege escalation. Again, this is all super easy to do because of the flexible REST API. And then whether our users are accessing from Southeast Asia and Azure, or US East 1 in AWS, or an Adobe data center, everything will be the same. It's all standard. There's no having to guess what's going to happen in any given region based on what you're pulling, right? So standardization has been key. Replication in Vault Enterprise has been key to our deployment. And then, of course, our auditors and our security people are super giddy about the information that gets provided in the audit logs. There are so many positive things that we've seen just in the 4 or 5 months that we've had Vault Enterprise deployed to production. My marriage has improved. My kids respect me now. Thank you. It's a fantastic product. I can't say enough good things about it. Later on today, 5:20, I believe, Chandler Alfin, our primary Vault deployment engineer and manager of that service, will be speaking on track A. So please, come by and see his presentation. Come talk to us, ask us questions. We'd love to answer questions. Thank you for the opportunity to be here, and I'll welcome Armon back on the stage. So.
Can we just give Dan one more quick round of applause? Thank you so much, Dan, for coming and sharing that with us. So earlier this year, we started working with our friends at Google, many of whom are actually here. So thank you to the Google folks for being here and supporting us. But we started engaging with them earlier this year on sort of advancing Vault's core mission, which is how do we support the users wherever they want to be? Our goal is really to look at providing a secure workflow to secure your infrastructure and your applications without being prescriptive about where you're running. So we're always listening to users and community members to understand where do you want Vault to run, where is it not working well for you. And something we heard over and over was, please add support for the GCP platform. So we started working with our friends at Google, and they've helped us to implement the Google IAM auth backend, which we launched earlier this year. And that's been awesome. So today I'm super excited that we get to talk about working with those same group of folks to add native support for Kubernetes. Probably right behind everybody asking us for GCP support has been everybody asking us for Kubernetes support for Vault. And so this is something that we've spent some time prototyping and spiking and working with the community to understand how to best do this. And we're really excited that we feel the implementation we got to is sort of the simplest and best of all worlds. So just to talk really briefly about how it actually works, now when you launch an application with Kubernetes, it's able to get a native Kubernetes service JWT token. With the Kubernetes auth backend, we're able to take that token and provide it to Vault. Vault will then locally do a cryptographic verification to make sure this token matches the role, this token is originating from the Kubernetes cluster, and that we have a strong guarantee that this service is who it claims. Then we go even further than that and call back into the Kubernetes API once we've done that check to verify this token hasn't been revoked, it hasn't expired, it hasn't been deleted for some reason. And once all this is done, then Vault will generate an auth token and provide it back to the service that is scoped down to exactly that service's role and configuration. And at this point, the service has a native Vault token. So it's able to directly communicate with Vault's API, make use of everything from static secret management, dynamic database passwords, encryption offload. It's not intermediated. The app can do anything that Vault really supports. And so what we really, really like about this integration is it removes a bunch of intermediate moving pieces. You don't have to worry about anything in between the Kubernetes API and Vault. There's nothing between the service and Vault. Everything is direct, and there's a native integration. And so we're super excited about how that ended up working. So this is landing in Vault 0.83. That's going to be available today or later today. So please download it, check it out. And I think one of the important takeaways is that this is part of our ongoing effort to work more closely with the Kubernetes community. Earlier this year, if you're a Terraform user, hopefully you saw we announced the native Kubernetes provider, which has support for the most common resources, and we're continuing to expand support for that. And so this effort is part of that as well, as we try and expand our support for Kubernetes across the portfolio. So I think you're going to see a lot more from us in that, and we'll talk about that as it shows up. So now I want to take some time to talk about Consul. Consul is our service discovery tool. And the challenge in talking about Consul, in some sense, is that it does so many different things, right? So when we talk about it being a service discovery tool, what does that really mean, right? In some sense, our goal is to provide a toolkit of features that really solve all of the different aspects that you really inherit the moment you go to a service-oriented or microservice architecture. The moment we go from one to many machines, now we have a service discovery problem. How do we actually know where our upstream services are running? We have a health checking problem, because now that there's many upstreams, some of them may not actually be healthy. We have a configuration problem. How do we configure our many different services? We have a coordination problem. If we want to run multiple instances of a service for availability, and one of them fails, and we want another one to take over, we need distributed locking tied into health checking, tied into discovery. So the list of kind of things that Consul needs to support to really effectively be able to solve this service discovery problem is broad. And so what you'll end up seeing then is a huge set of features and capabilities that we're constantly adding to support this. So this is just a small preview of all the things that Consul has gained in just the last year. And one of the things that's always been super important to us when we thought about Consul, when we first built Consul, when we designed the system, was realizing that because of the role it plays, because you're depending on it to do this service discovery, this health checking, this configuration, it acts as kind of a dial tone to the data center. All of your services are using it to look up their upstreams. Health checking is being used to do automated failovers. And so it's very, very sensitive. And if it takes down, it can have a lot of collateral damage to your data center. And so from the very beginning, it was important to us that the system be rooted in academic research, and that we're really delivering a world-class, state-of-the-art system to make sure we're giving you the highest level of sort of availability and performance and ability to tolerate failures. And so there's really two very important subsystems. One is Consul's gossip subsystem, which allows it to scale linearly to data centers with thousands of nodes and effectively be idle. And this gossip subsystem is based on a work called SWIM. The other really important subsystem is its consensus and replication system. This is based on Raft, which is simplified Paxos, which is a consensus algorithm. And so what this lets us do is replicate Consul state between multiple servers and gracefully handle the failure of any of those servers. And so this lets us give you these guarantees that the system will both scale and stay online. So in the last year, we were really excited when we announced the launch of HashiCorp Research. And our goal was to really recognize that we consume a lot of this research from academia and use it to build our products. It's at the heart of many of the tools we build. And so we wanted an opportunity to give back as well. We wanted to be able to do our own novel research into algorithms, into system designs, into empirical analysis of what we're doing with these things, and then publish that and give back to the community that we owe so much to. And so I'm super excited that in the last year, we published our first ever paper. We call it Lifeguard, Swimming with Situational Awareness. You might claim we got a little overly clever with it, but we had fun with the title. The core sort of inspiration of this was really actually working with one of our largest users who was experiencing a denial of service attack. So they were under a denial of service, and their front-end machines were getting just totally slammed. And then they noticed that for whatever reason, random machines that aren't on the front end, Consul's declaring as failed. Right? Machines that are not publicly accessible to the internet, that are not affected by the DDoS, are just being marked as offline, but are being marked as failed. And so this was a really interesting opportunity for us. And so they brought us in and worked super closely with us and gave us access to their environment to really understand what's going on under the sort of pathological condition of the DDoS. And what we found is there was a number of shortcomings in the underlying gossip protocol, that it made certain assumptions that under cases like this, where some nodes were heavily degraded, would degrade the entire cluster's performance. So we worked with them, and we worked internally with HashiCorp Research to come up with a number of novel extensions to the way SWIM actually operates to work around these issues. And the results are kind of amazing, honestly. They beat even our own expectation. What you can see on that graph is basically sort of the baseline system on the left, which is pre-Lifeguard. And just by enabling Lifeguard, no other changes, no other configuration to the system, we can see a 98% reduction in the rate of false positives in the system. And so this was kind of crazy for us, because some of our customers run data centers with tens of thousands of nodes, hundreds of thousands of console agents in a single cluster. And so this 98% reduction for them is huge. Console basically goes completely quiet in terms of flapping. And so we were able to take some of this benefit, some of this sort of 98% reduction, and actually tune the system to not only have a dramatically lower rate of failure detection, but also to detect failures even faster, because there's so few false positives. So we're super excited about this. Our Director of Research, John Curry, is here. He's going to be giving a talk about Lifeguard. So if you're interested in the nitty-gritty of how this actually works, please make sure to attend his talk. One of the things that sort of come from this relentless focus on operational stability and scaling has been that we've seen an incredible amount of adoption for console. Right? It is now deployed in some of the world's largest video streaming companies, some of the world's largest financial institutions, some of the most trusted news sources, and some of the largest consumer tech companies. And partly it's because of this focus, it's the sort of relentless polish we put into the system so that it actually works at their scale. And this has not been overnight by any means. Console has had a long, long history. Many of our earliest users have suffered through some really atrocious bugs, and we apologize. And we've come a long way since then. And so this has been a slow and steady but relentless march to improving the system. I think many of you probably know where I'm going with this. And so we're very, very excited today to finally announce Console 1.0. It was really only now it's our third product. Vagrant actually just got to 2.0 in the last 2-3 weeks here. But it just joins Vagrant and Packer as HashiCorp's only 1.0 products. And for those of you who've never had a chance to sort of read up on our philosophy of it, it's not because our tools aren't used in production. It's not because they don't see scale. It's just that HashiCorp holds such an incredibly high bar for what we're willing to call a 1.0. We really want to make sure we understand what is the total surface area of the use cases? How are people using this thing? Does it work even at these most massive scales? And make sure that it reaches our level of fit, finish, and polish before we put that 1.0 label on it. So rest assured, this is not an end-of-lifing announcement for console. There is a long roadmap ahead of it. Sometimes it just takes us 4 or 5 years to actually get there. So Console 1.0 is going beta today. It's available. Download it. Check it out. Let us know if there's any last-minute issues before we take a 1.0 Gold Master. Next, I want to spend a little bit of time talking about Nomad. Nomad, for those of you who've never played with it, don't know about it, is our batch and service scheduler. And so its goal is really to enable you to specify whatever your workload is, whether it's a cron job that you want to run every hour, whether it's a Spark job that it's doing big data processing, whether it's a long-running service, and just specify at a very high level what you want Nomad to do, and then Nomad to abstract the details of how to run it, where to run it, all of those details. As you might imagine, for a system that's trying to do all of these things, there's an incredible number of asks. There's so many things people want the system to do. I want rolling deploys. I want blue-green. I want canaries. I want manual promotion. I want Datadog, Prometheus, so on and so forth. The sort of surface area of what people want, because this thing sits so core to the data center, is broad. And so we've been super busy adding all of that. So Nomad, this is just a small set of the things it has gained in the last year. It's been sort of an incredible march to roll out all of these features. And so I'm super, super excited to welcome Mohit Arora on stage to talk about how Jet.com is using Nomad.
Good morning, everyone. My name is Mohit. And I'm part of Cloud Platform team at Jet. For those of you who are not familiar about Jet, Jet is an e-commerce company based out of New Jersey. We are part of Walmart family now. Jet was acquired by Walmart late last year. Our value proposition for our customers at Jet is that prices drop as you shop. So as you build bigger baskets, as you add more items to your shopping cart, our system in real time tries to compute the savings based on the supply chain efficiencies that can be brought in to fulfill your order, and we pass on that saving back to customer. To a quick example, if you are buying a shirt at Jet, $25. If you are buying a second shirt at Jet, normally on all other e-commerce platforms, that will be $25. But here, if it is coming from the same merchant, can be shipped in the same box. These are the supply chain efficiencies we are talking about. And the second shirt that you buy at Jet might be $20 because of the supply chain efficiencies that can be computed in real time. So Jet was born in cloud in 2014. And all the systems that power Jet.com run in public cloud, which is Microsoft Azure in our case. Our journey with cluster schedulers started late last year when we were trying to bring the utilization of our platform up. We are trying to drive the cost down. So we were trying to compare all the schedulers which are out there in the market, and we ended up comparing Nomad and some other schedulers which are available. So all these distributed schedulers promise you similar things, but Nomad won for us primarily because of these 4 things. So first is cross-platform. So our applications are built in F#, and our cloud platform tools are written in Golang. So our F# services run in Windows in production. So we wanted to have a distributed scheduler which can support both Windows and Linux, and Nomad was the clear winner for us. The second is flexibility. So even though we were big on containers, but we had legitimate use cases where we want to run some workload out from as a general purpose workload on the instances not packaged as a container. And Nomad also gives us that flexibility that we can either run a general purpose workload or we can run a container. Ease of use. So we were heavily invested before Nomad in console, and Nomad and console have same semantics. So we already knew how to run console in production. When we tried Nomad out, it was pretty easy to get started with. So that also played a factor in our decision. The last is the fantastic console and Vault integration. As I said, we had a long list of use cases that we drive out of console, and Nomad has out-of-the-box integration with both console and Vault, and that was also a factor when we were making a decision. So after we picked Nomad, we built an ecosystem around it. So we never exposed Nomad directly to developers. So what we essentially ended up doing is that we built a tool in front of Nomad, and all we ask developers to do is in their version control system, they check in a file called manifest file, a couple of manifest files. One is service manifest file. But essentially, a service manifest is what your service is, what our health check of its service, of that service. And then the deployment manifest file. Deployment manifest talks about how do you want to deploy that service, if it needs to be co-located with other services, and all that. And rest of the magic is done by this tool that we have built, which we call Gizmo, in front of Nomad. Gizmo does all the stuff, and then ultimately it creates a Nomad file that it deploys on the Nomad cluster. So when we kind of took this Nomad as a platform, and on top of that, this tooling, we exposed it to developers. These were the immediate benefits that we saw. The first is continuous delivery story. Developers love the fact that they can define how their services needs to be deployed in version control system, and then rest of the stuff is taken care for them by Gizmo, but they can go back to their version control system and run the next run of the build, and it'll update the configuration for them. The second important win for the app dev team was geo-redundancy story. So in Jet, we run services in multiple modes. Some of them we call hot, like depending on what it is doing, or hot-warm, hot-cold. So if you are writing a service, it has to opt for one of these models, which further defines how it will be deployed on multiple regions that we run out of. So with this journey in the manifest file, developers can pretty much define which mode they want to run their service in, and everything else is taken care for them, and they love this fact. Scaling. So before Nomad, if the app dev teams are worrying about scaling, they are worrying about the compute infrastructure as well. So in this offering, what we have for them is that we have a separate process which keeps monitoring the Nomad infrastructure, and if it needs to be scaled up, it scales that up. And developers pretty much have the guarantee that if they need to scale their service up, it'll be pretty quick scaling effort for them because the infrastructure is already scaled up for them. They don't have to worry about it. The next is operational excellence. So in the service manifest file, as I talked about, developers can define health checks. We also let them define their PagerDuty service key. And on all the ecosystem that we have built, we keep monitoring their services on their behalf. We have a handle on their PagerDuty key if it is crashing, and then we can page them. So they love this fact that they don't have to do anything. Everything is taken care on the ecosystem that's built on top of Nomad. The last is the canary deployment and experiments, which our business users love. So like any other e-commerce company, we run a lot of experiments at Jet. And we kind of try to figure out what's the conversion related to each experiment so that we can run that experiment longer. So Nomad allows us to run multiple versions of the app on the platform. And then we have built a tool on top of it, which we call Phaser, which allows you to phase the traffic from one version to another. And then we do some things at the proxy layers, at the headers, and business users can correlate what's the conversion impact for each of the version that's running in production. And huge win again. So this is how our production cluster looks like. I know it's not a huge cluster in any way, but where we are right now is that we have proven the platform and we have proven the ecosystem that we have built around it. And it's a completely self-service model. And at this point of time, there's a greater push within the company to move all the services which are not data stores on top of Nomad. And before holidays, the idea is to run everything that we accept data stores on top of Nomad. And in early November, I expect this number to be going up close to 400 nodes. And as we speak, 50%, we have already migrated the front end, which is a Node app for Jet.com on Nomad, and we have phased 50% of our traffic on that version of the application. And before holidays, we plan to go 100%, and all other services, even though they are not serving customers directly, will also be running on top of Nomad. And so, yeah, that's it. Do check us out during holidays. We'll have some great deals going on as well, and the platform, and the platform will also be running on Nomad. Thank you.
Awesome. Can we give one more quick round of applause for Mohit for sharing Jet.com story? So something we've seen over the last year is increasing adoption for Nomad, both at small organizations and large ones like Jet.com. And a frequent piece of feedback we've gotten is it can be really hard to onboard new users onto Nomad in these organizations. You have a core that has operational sort of expertise and knows how these systems work and understand Nomad in depth. But for everyone else, it's sort of a new mental model to learn. It's sort of foreign when they start trying to learn about the operational side of things. And today, really, Nomad exposes everything through an API and a CLI, which can be sort of unfriendly for some of the users. So to help make that a little bit better, we're excited to have a first-class native integrated UI that we want to show you today. So this will operate very, very similar to the console UI. If you've ever used that, it'll be integrated into the binary. You just flip a single flag, and it'll be served from the same set of processes. And now you get a native experience that we're committed to adding support for all of Nomad's features. I'm just going to show through a few of the screenshots of it. It's a much richer interface. I recommend downloading and playing with it. But here it gives you a feeling for what it's like when you have multiple jobs running on the system. And at a glance, you can see what type of job it is, the priority, what state the various allocations of the system are in. On the other side is what we get if we drill into a particular job, if we want to understand what's going on with this particular application. And here it's sort of highlighting one of the features that we shipped earlier this year, which is Nomad's ability to do canary deployments. So in this case, the application is sort of canarying one of its instances to run the new version, and it's waiting for an operator to come in and do a manual promotion. So it's deployed out the new canary, it's running, and it's just saying, whenever you're ready, give me the go, and we'll continue the rollout of the rest of the service. And so this is an example of the kind of things that we want to make more visually obvious to users, make it easier for developers who are self-servicing and doing canary deploys to be able to do that on their own. Here's an example of another feature we shipped earlier this year, which is multiple job versions. So now Nomad will track the last few versions of a job. And one of the reasons we're doing that is so that we can show you what's changed. So if there's an anomaly in the performance, the service isn't acting exactly as you expect, or maybe it's acting better than you expect, and you want to know what changed, why is this happening, you can go into Nomad's interface and ask it to basically show you the delta. What's changed between these two job definitions? It might be something as simple as just the version of the job. It might be that the resource allocated to it is different. But now you can sort of drill in and see these versions. And if something's wrong and you don't like the current version, you can push a button and revert back to a previous definition of the job. On the other side, you see what it looks like when multiple jobs are running on a single node. So this is sort of a node-oriented view of the cluster as opposed to a job-oriented view. So what Nomad is doing in the background to increase resource utilization, to solve the problem that folks like Jet.com are saying, is it's trying to bin pack multiple applications onto the same node. Typically, what we see in most clusters is less than 5% utilization in a world without schedulers, and most of these resources are just idle. And so what Nomad's trying to do is understand what are all the resources available and try and fill that in to get you much higher than 5% resource utilization. And so because you'll be multi-tenant, you can look at an app, or I'm sorry, at a node and understand what are all the different jobs and services that are being serviced by this particular node. There's a lot more in the Nomad UI. I only had time to show off a few of its features. It's available now, so please download it, play with it, and give us any feedback you have on how to improve it. Another thing we talk about all the time with Nomad is this separation between the concerns of developers and the concerns of operators. So from an operator side, we'd like to be able to stand up this cluster, make sure it has enough capacity, run the developer jobs, that it's healthy and available. But then we want to be decoupled from what the developers are trying to do. Whether they're trying to submit a new job, whether updating a version of a job, scaling up, scaling down, rolling back, whatever it is that they're doing, we don't necessarily want to be tightly coupled in this capacity as being an operator. And so while the UI certainly helps with this, it makes it easier for the developers to self-service and not necessarily have to understand the whole system, it raises this other question, which is, how do we do this safely at scale, right? It works if we trust all of our operators, trust all of our developers, but as we open it to a much broader community inside of our organization, how do we sort of do this without losing sleep? So to make that a lot easier, today we're also announcing Nomad's ACL system. This is building on top of what we've learned with Console's ACL system and Vault's ACL system. And so there's a few sort of twists. It's a little bit different from both of them, but sort of conceptually very similar. At the heart of it is a set of role-based ACL policies. So we can define what are roles for our developers, what are roles for our operators, what are roles for our DBAs. And with each of these roles, to give out sort of these very fine-grained capabilities. So we can decide maybe our developers are able to submit a job and update a job, but not able to access the logs that those systems are generating because they might contain PII data or sensitive data being logged out to disk. So you have this very fine-grained capability system that lets you dole out exactly the kind of permission a developer or operator needs to interface with the system. Those then get tied back into ACL tokens, which can be used to make requests to the system. And so because we're announcing the UI with it at the same time, this is natively integrated. So if you're using the ACL system with the UI, developers can put in their credential and just interact with the system like normal, and the UI will take care of threading through the credentials correctly. So that's all we have for the Nomad ACL system. There's a lot more detail of it. If you want the gory guts, all of the documentation will be up to date. And all of this is available as part of the Nomad 07 beta. This includes both the UI as well as the ACL system and a lot of other features that is available today. Something we talked about for the first time last year was what we call the Nomad Billion Container Challenge. And so when we were designing Nomad initially, we really wanted to make sure that this is a system that would scale with our users, that they don't have to architect around it. So when folks like Jet.com go from 10% traffic to 100% traffic, they don't have to have that moment of, oh shoot, now we're re-architecting around the core element of our system. And so what we wanted to do was design it with a benchmark, a sort of stress test in mind that we thought was obscene enough that nobody would ever hit it. And so we're like, million containers, no one's ever going to need anything more than this. Let's set this as our design benchmark. And so we partnered with our friends at Google. They gave us access to 5,000 machines on GCE and said, run wild with this. And so we submitted 1,000 jobs, each with 1,000 Redis containers. And so I think, at 1 million Redis instances, we might comfortably have run the world's largest Redis cluster. And what we found is that we could actually schedule all 1 million of these containers in under 5 minutes. And so this was great. We were super excited that we hit our design threshold. We're like, we never have to worry about it again. Mission accomplished. And then we got a call from Citadel Group, who's here. They'll be speaking. And they're like, that's cute. We need to go even bigger. Can it do it? And we're like, you guys you're making our lives difficult here. And so this was really exciting for us because on one hand, we're like, well, no one's ever going to hit this. And then on the other hand, it was this really nice validation that it is useful. There are people who are operating at this scale and need this. And so what we're really excited about today is the availability of Nomad Enterprise. So really looking at how do we support some of these enterprises that are truly operating at this gargantuan scale and looking at their unique problems. So one of the things that became very clear is access control is needed by everyone at sort of any scale. Even if we're operating a very small cluster, we need access control so that we can safely move away from the assumption that being on our network means you're authorized to do things, right? It's part of our ethos around things like Vault that network access should not mean authorization. But going even further than that, what we've heard from some of these organizations is they're not really one organization. They're actually many different lines of business sort of housed under one roof. And so they need to go even further than just having an access control system and have native ability to multi-tenant a single shared cluster. So as part of that, Nomad Enterprise adds the support for native namespacing. So now you can have separate namespaces for lines of business A, B, and C, and each of these things looks like a virtual cluster in and of themselves. They have their own sort of view of the cluster. And so this lets them much more easily multi-tenantly share a single cluster. Now, it's not enough just to split it into what looks like a virtual cluster, because you still have to worry about quality of service. You don't want one line of business to consume all the resources of this shared cluster and starve the other lines of business of resources. So attached to those namespaces is the ability to quota each namespace to a specific amount of resource utilization. So this way, line of business A can consume their resources and do it safely without impacting line of business B's ability to do what they need to do. And all of this is supported with Nomad's native multi-region support. So whether you're using Nomad just to submit jobs across multiple regions, if you enable ACLs, we replicate policies and manage those globally. If you define namespaces or quotas, those are all managed globally and support the multi-region setup of Nomad. And so that's all we have for Nomad. At this point, I'd like to welcome Mitchell Hashimoto back onto the stage. Thank you guys so much.
Thank you very much, Armon. Those were a lot of exciting updates, a lot of great things, console going 1.0, a UI available for everyone in Nomad, really, really exciting stuff. And so I hope what you see is that every product is growing and maturing faster than we've ever been able to do it before, and we're really excited to have been able to share with you some of these exciting new features. And so what we're seeing, really, is that the growth of infrastructure and applications has been really enabled in a big part by the ability to automate more effectively. Going on this undated timeline, back to configuration and code and the rise of virtual machines, those things enabled fast, automatic machine setup that we didn't have before. And then cloud providers, infrastructure as code, and tools such as Terraform are enabling fast, automatic infrastructure creation that was difficult to achieve before. Trends like containers and microservices allow us to much more easily package our application runtimes and get them out there. And then schedulers have enabled automatic application placement, deployment, as well as operational tasks such as rolling deploys and so on that have allowed us to just deploy a much larger number of applications. And so automation has brought all these really amazing capabilities that were simply not really possible before. However, it's also brought a number of challenges. For example, in the age of VMs and manual procurement, if you place an order for 5,000 new machines, a human would probably call you and say, like, are you sure this is the correct order? Or if you tried to deploy an application that was requesting all the resources of your biggest machine, again, someone would probably stop you and say, like, is this what you truly meant to do? But today, with automation, these things could just happen, and they happen really, really fast. And so today, we want a way to enforce problems such as forbidding changing configuration outside of business hours. This is a pretty easy way to introduce instability, page people, have people work at times you don't really want them to be working. It's something you want to check. Or ensure all services have associated health checks, We want to make sure that every service we deploy can be monitored at least at some minimal level before it's actually running and serving user traffic. Or verifying that all the TLS certificates that we issue are encrypted with a key size of at least 2048 bits, just to ensure some minimum expectation of security. Or perhaps to ensure that all instances we launch in scenarios where we have multiple lines of business have a billing ID tagged with it, so we know which organization is using this. And these are all problems that previously could have been easily solved with human verification, but today is very, very difficult in the age of automation. And so today, what I'm happy to announce is the availability of something we call Sentinel. It's a system and framework for policy as code. Sentinel is an enterprise-only feature that is being integrated into all our products. And to see how Sentinel solves some of these problems, let's take a look at those examples one more time. So each of these examples actually corresponds with a HashiCorp tool that's capable of automatically solving that problem in combination with Sentinel. And going through each one, if we take a look at the first one of Console Enterprise, we'd like to forbid changing configuration outside of working hours. And this is actually the associated Sentinel policy that would enforce that. We're going to cover language, syntax, some other things a little bit later in detail, but I hope what you could see here is that it's pretty easy to understand and see what it's doing, which is verifying that all keys that start with the service namespace can only be modified within the standard business hours of 8 a.m. and 5 p.m. And if we take a look next at Nomad, we want to ensure all services have associated health checks. Equally easily, we're just looking at the job structure and verifying that all tasks that are within the job structure have at least one health check associated with it. Moving on next to Vault, where we'd like to maintain some base security by ensuring all TLS certificates are encrypted with at least a 2048-bit key. We could do this by making sure that when a PKI role is created, which is how you define who could create TLS certificates within Vault, that their minimum required bit size is always at least 2048. And then finally, with Terraform, ensuring all instances have a certain tag that we expect. This one, we could go over a plan that's been made and verify that any AWS instances in the plan contain a billing ID tag. These are 4 common problems that real customers have brought up to us over the years, and they all now share the same easy solution. And that solution is what we call Sentinel. And so those are the problems that Sentinel can solve. But what is it? How does it work? Let's take a look at that next. So Sentinel embraces this concept that we call policy as code. And what policy as code does is bring all the same benefits you know and love with infrastructure as code and bring them down to policy. And by representing policy as code, we're able to use proven software development practices with policies. And this is in contrast to other policy systems that use graphical user interfaces for updating or application-specific endpoints, because the problem with these is that they're very difficult and not easily repeatable, versionable, or most importantly, testable. And Sentinel solves all of these cases. And to do that, Sentinel is really 4 separate things. It's a language, it's an embedded framework, it's a workflow, and it's an ecosystem of imports. And so starting with the language, Sentinel does use its own policy language that was designed specifically to make writing policies easy. We designed it with hundreds of customer examples and translating those from English into the policy and trying to make that as easy and straightforward as possible. One of the things we found was that a lot of the people that are responsible for enforcing this policy within businesses do not have a strong programming background. You cannot throw at them a programming language because they're not comfortable doing that. But with something like Sentinel, where it almost becomes English and it's almost one-for-one, they were able to effectively write and enforce policy across multiple systems. It was also built to be safe in a highly security-sensitive environment such as Vault. Sentinel is integrated with Vault, and we can't compromise the security of Vault because of it. And so that was designed with that in mind. And then to run this language, Sentinel is an embedded framework. And embedded is a really important word, because what that means is that Sentinel itself is built into the applications. You don't run another application next to it. You don't have to deploy something new. And Sentinel is actively right in the data path of what's happening. And so what this lets you do is what we call active enforcement. Sentinel actually actively sees a behavior coming in before it takes effect and can perform policy checks on that behavior at that time and reject them if they fail. So you don't detect after a key's been written to console. You don't even allow that key to be written to console in the first place. The policies run right there. But while we do active enforcement, Sentinel is also capable of passive enforcement. So Sentinel can continuously run in the background and continuously check the state of your systems to ensure that they haven't been pushed into a policy-violating behavior by some external force. So for example, with Terraform, we could continuously run Sentinel against the Terraform state, and if someone goes into something like the AWS console and deletes a tag, we will detect that your system was pushed into a policy-violating behavior outside of the Terraform workflow. Sentinel also natively supports the concept of what we call enforcement levels. And the enforcement levels it supports we call advisory, soft mandatory, and hard mandatory. Enforcement levels are broad types of policies that we found existed across all of our customer advisors while building Sentinel. Advisory policies allow a policy to fail, but actively show a user a warning of what failed and why. These are useful for scenarios where you'd like to educate a user that they're perhaps doing something not quite right, or if you're deprecating something and you want to warn them that they shouldn't be using this version anymore. Soft mandatory policies require that the policy pass, but it could be overridden with the proper privileges. These privileges may be the same person, they may require another person. And these policies are super useful in cases such as don't allow deploys on Fridays. Deploys on Fridays, easy way to get people working late or over the weekend. Maybe that's not a good idea, but of course you have to deploy sometimes on a Friday. Things happen. So soft mandatory policies are a way to require an explicit override, an explicit acknowledgement that you're doing something that could be dangerous. And overrides always appear in logs so that you know when overrides happen, who initiated the override, and who initiated the original request as well. And then hard mandatory levels cannot be overridden and must pass under any circumstance, short of actually removing that policy itself, which itself is a fairly privileged operation. And hard mandatory policies are really great for business requirements as well as legal compliance and assisting in making those a little bit more robust. And so we have the language and we have the embedded framework to actually run that language and enforce policy. And we think the Sentinel is a really great technology, but having a really great technology just isn't enough and doesn't solve the actual core problem that we're trying to solve. You also need to think about the development, test, and deployment workflows of these policies. We think those are just as important as actually building a powerful policy system. And so what we've done is build into Sentinel a powerful workflow. So Sentinel ships with a local CLI that we call the Sentinel Simulator. The Sentinel Simulator is a single binary with 0 dependencies, and it lets you write and test policies against any Sentinel-enabled system without access to that system, all locally on your own machine. The policies are developed in text files. We are pushing policy as code, so you code your policies in text files, and they could be run using a command called Sentinel apply. This command can mock any data that a system exposes to your policy so that you could develop that policy without that system. And when policies fail, you could also see the failure, but also the logic that led to that failure and the various rules that passed or failed that led to that result. In addition to simply developing policies, evaluating them locally, seeing if they pass/fail, we expect all our customers and users of Sentinel to eventually grow to hundreds, thousands of policies, and reasoning about those, ensuring they behave correctly, is extremely important and is a challenge today. So Sentinel also includes a full test runner and test framework within the Sentinel simulator that you can use to test your policies. And what this looks like here is you define an environment in which the policy is running. Again, you mock all the information that the system would give you. You don't have to run console. You don't have to run Vault. It all just runs in memory. And what you do is you assert that the policy behaves as you expect. But you don't just assert that the policy passes or fails, because perhaps that policy is passing or failing for some completely unrelated reason from what you're testing. So you could also assert the various logical rules that led to that pass or fail, so that you know it's passing or failing for the reason you expect. And this CLI was designed to run in continuous integration environments. So you could see no parameters, as long as you follow the right folder structure, will run thousands of policy tests automatically, all in memory. And we're encouraging everybody to run this in their CI environments to constantly have continuous testing of their policies. This also lets it work extremely well with version control, pull requests for policies, etc. You get all those benefits directly with Sentinel that you can't get when you're manually editing policies directly through a system. And so that is the powerful workflow Sentinel provides. And the last thing I want to talk about is the ecosystem of imports. Sentinel can use plugins that we call imports to source external information for use in policy decisions. And this is a really extremely powerful concept, especially once you think through the ramifications of this. Your policies aren't limited to only the information that the system is giving you to make that decision. You could query and get information from any external system you want in order to make your policy decisions. So as an example, we have a customer that uses Terraform that also uses ServiceNow that wants to ensure that their Terraform changes can't go into infrastructure until there's a change management request in ServiceNow that matches that change. And they could do this with Sentinel by writing a plugin. These plugins are exposed to Sentinel as imports, and imports expose functions and data you could use within Sentinel to make these decisions. And the Sentinel simulator can also mock all of this data. So you don't even need access to the plugins. You don't need to have access to a ServiceNow cluster if you're writing that plugin. You can mock all of it locally to still develop policies against this right on your own machine offline. And anybody could build a Sentinel plugin using the SDK, which is publicly available. The SDK provides a test framework to verify your plugins and gives you examples in order to build these things so that you could work with any external information source. And these plugins then work with any Sentinel-enabled application. So for example, if I wrote a plugin that sourced data from S3, the moment I build that plugin, I can now source data from S3 in console policies, Nomad, Vault, Terraform, all of them without modifying that binary. The plugins use our production-ready plugin system we've developed for the past 5 years and build on top of it. And additionally, the plugins use the new gRPC mechanism in our plugin framework, so you could write plugins in any language. And those are the 4 aspects of Sentinel that make it a really incredible system for policy as code. And as I said earlier, Sentinel is integrated natively into all our enterprise tools. It's available in the next version of each, and it's ready to go. I'd like to show you what it looks like in each of those. So with Terraform Enterprise, you could define policies that run between a Terraform plan and a Terraform apply. And these policies have access to the entire Terraform configuration, the Terraform plan, the Terraform state, and a simulated version of the state after the apply. So you could use all of this information to determine if an apply is allowed to happen. And so this is the same example as previously, but you can see we're going over the plan to verify it has a tag. Equally, you could go over the plan to verify, for example, that no tags are being removed, that only tags could be added. You can't remove things. You could do just about anything with this. With Console and Console Enterprise, you're able to define policies that run during KV modify events, as well as service registration and updates. And so in these scenarios, you could enforce whether a KV modify is allowed to happen or a service registration is allowed to happen. And so in the example I have here, what we're doing is if the service name is prefixed with a user and a hyphen, we're enforcing that that must be deployed within a CIDR block that perhaps has higher levels of security or monitoring or something. We just require those services to live in that CIDR block, and we can enforce that right here. With Vault Enterprise, policies are split into 2 types of policies. We have what we call role governing policies, and we have what are called endpoint governing policies. Role governing policies are attached, as you might expect, to roles. So whenever you make an API request using a token that has that role, we execute that policy. Endpoint governing policies are attached to specific API endpoints, whether you're authenticated or unauthenticated, and whenever you hit that endpoint, we execute that policy. Both of these policies have access to the same amount of data, which is a lot. You have access to the full identity of the person requesting, you have the full request package, and a lot more. And so in this example, what we're actually doing is ensuring that people who log in with LDAP are only allowed to request read-only database credentials. You must log in with another mechanism in order to get write database credentials. And then with Nomad Enterprise, you're able to define policies that run before a new job is created or a job is updated. And these have access to the full job definition that's being sent. So what you could do with this, in this example, for example, is ensure that all tasks, all jobs that are deployed into the Nomad cluster are sourcing their artifacts from an internal Artifactory instance. They cannot source artifacts from an external source. And you can see sort of where you could go with this and the amount of power you actually are able to have. And one of the customers that we worked with in the design from the very beginning with Sentinel was Barclays, one of the world's largest financial firms. Barclays is planning on using Sentinel to provide safety guardrails for provisioning cloud resources. This will allow their expert operators to define reusable Terraform modules within the registry, best practices with Terraform, and give them out to over 15,000 users of operators within Terraform, and know that they're safely using Terraform across their entire organization. It's really great to see how Barclays is going to put Sentinel to use in their cloud, and we have to thank them for being really great customer advisors during the design of Sentinel. And so we're really excited about Sentinel, and you could learn about it today at HashiCorp.com/Sentinel. And with that, I'd like to invite to the stage our CEO, Dave McJannon.
Thank you, Mitchell, and welcome from me. It's, as Mitchell mentioned, it's actually our third HashiConf, but what he didn't mention is it's almost exactly 5 years since the founding of HashiCorp itself. So the velocity of adoption of our products has actually been kind of amazing. For a relatively short period of time, to see the number of people that put up their hands when we asked who was running this in production is a big number. But what we really saw over the last 24 months is almost sort of a step function shift in adoption, not just by end users, but also by the partner ecosystem around us. And you saw that from some of the announcements that came out today, where our products are being used not just by some of the largest entities in the globe to run their own infrastructure, but also increasingly underpinning sort of foundational elements of the cloud ecosystem, which is really, really fun for us. But it's also something we take super seriously. And so as a company, we've been, for the last 12 months, investing super aggressively. And we've been really investing across basically 3 vectors. One of them is around the product and engineering organization itself, where our engineering organization, as you can see from the 150 releases that we put out over the last 12 months of our core product portfolio, has more than doubled in the last 12 months. And it'll continue to expand, if not double again, over the next 12 to 18 months. Secondarily, we recognize that a lot of our users are sort of navigating this transition from a relatively traditional way of running infrastructure to a more cloud-oriented approach for running infrastructure. It may not always be on cloud infrastructure, but philosophically, it's a slightly different way of running infrastructure. And so we've invested really, really heavily in our support and success organization to help customers navigate that transition. And the third, and this has been a really big push for us, is we recognize that we need to be with technical expertise where our users are. So we over the last 12 months have established presence really all over the globe. We now have technical resources on the ground on the East Coast, on the West Coast, in the Central, in the Federal area. I was in London last week. We have, I believe, 8 people in the UK today. We have teams in Japan and Australia. We also have customers in Korea. And that is something you'll see us continue to do, because this, in our view, is sort of a generational shift of how infrastructure is deployed and run. And so we need to be where our customers are, not just sitting remotely from our offices here. And I think, actually a good example of this, it caught my attention that the London meetup group alone for HashiCorp is over 1,500 people, right? So it's not even affiliated with us necessarily, but it gives you a sense for the stuff is used everywhere. But it's really the engineering organization and investments that have allowed us to make the announcements that we made today. And I just wanted to play them back because, as you see, we believe strongly that there are 4 essential elements of infrastructure, right? There's a provisioning layer, there's a security layer, there's a runtime layer, and then there's the need to connect everything together. So what we announced today was actually updates across that entire portfolio. On the Terraform side, we announced the Terraform module registry, which, as I can tell on Twitter and on Hacker News, is already super popular. I think it's going to put some pressure on our operational teams to, to match it. Also, the newer version of Terraform Enterprise, which adds collaboration and governance capabilities to the running of Terraform in a large organization, as Mitchell identified. Secondarily, we announced Vault Kubernetes support, which has been a real request. We realize there's a lot of heterogeneity across infrastructure stacks, and it's important to us that we enable people to run the technologies of their choice. Kubernetes has been an important one for us. Console 1.0 and Nomad 0.7 are huge. And then we introduced Sentinel as a really sort of a governance model to apply across all 4 layers of our stack. And while the company's changed a lot over the last, let's call it 24 months, the philosophies that underpin how we think about the world really haven't, right? Mitchell and Armon started this journey with the view that enterprises are heterogeneous things. Yesterday it was virtual machines, tomorrow it'll be, today it's containers, tomorrow it'll be something else. And so what we do instead is we focus on the workflows, not the technologies. You see that in our approach and philosophy with respect to Terraform, where not only has the provider ecosystem expanded as it relates to support for more and more cloud infrastructures, for example, you saw some of the ones today, but basically across any infrastructure type that you might choose to provision, there's a Terraform provider support. But more interesting to me, actually, is there are now more than 70 Terraform providers, and we have a queue that we're certifying of another 10 behind that, because as you all in the room have used Terraform to provision infrastructure to your cloud partners, the ISV vendors that you work with that must be included in that provisioning experience have stepped up and created Terraform providers to allow their products to be provisioned as part of that single experience. It is that focus on the workflows, not the technologies, which just underpins our whole philosophical approach. The second core principle is around automation through codification. That's a belief in immutability and the need to codify given the scale of the environments we all operate. Sentinel is a good example of how we are now applying the governance model for distributed infrastructure through codification. Sentinel also includes, I should add, the ability to extend to the plugin mechanism to whatever backend system you may want to connect to that experience. So the philosophy around openness and extensibility, recognizing that you need to be able to extend our products to your specific environments, which are highly differentiated, as any large company is, those remain the underpinnings for how we think about philosophically our approach. So I know it's been a long day. And we're certainly honored that you chose to spend a couple of days with us. We know it's a big deal for all of you to take your time away. I wanted to call out, despite the fact that we have a really, really rich agenda, I just wanted to call out a couple of things. There are deep dive sessions on Sentinel, the module registry, and also on all the new product announcements that we made. I also would make sure you attend our evening social tomorrow, as well as the hub next door. I know a lot of people were there last night. So with that, thanks for coming today. We hope you have a fantastic couple of days. Thank you very much.
Hello, hello again. Look at you people trying to leave. Sit down. Thank you very much. Hopefully you've enjoyed all of the announcements in this morning's keynote, but I do need to clarify a few things. You may have noticed that the first 2 talks are not across all 3 tracks. They're only in track B and track C, and they were a little bit obscure on the schedule. And the reasons are because they correspond to 2 of our major announcements this morning. So if you're interested in Sentinel, Nick Jackson from HashiCorp will be talking and doing a deep dive with demos on Sentinel this morning in track B. In track C, we have folks at Gruntworks who are talking about the Terraform module registry and Terraform modules in general, how to build reusable Terraform modules. There will not be a talk in this room for the first session. So tracks B and C are the only tracks that are running. We do ask that everyone leaves this room because we have to prepare it for the talks for the remainder of the day. So after we're done, please do exit. We have a short break. so we have about 20 minutes. The next talks will start at 11:45. Please make your way to the hub or other seating. One last thing. As you may have noticed, this room is a little full. We had to bring extra chairs in this morning. There will likely be standing room only for tracks B and C. So if you're interested in attending those, please get there early. And we apologize in advance if we are not able to get you a seat, but we're working on adding more seating to those rooms. Thank you very much. We look forward to seeing you through the rest of the day. Thank you.